Have you ever wondered how a plane works? There's something quite magical about how a massive machine like an airplane can soar through the skies. But it's not magic, it's science. Specifically, it's all about four fundamental forces of flight: lift, weight, thrust, and drag. Let's start with lift. Lift is the upward force that pushes a plane into the air. It's created by the air pressure differences above and below the wings. Picture it like this. The air traveling over the curved top of the wing moves faster than the air underneath, resulting in lower pressure above and higher pressure below. This difference pushes the airplane upwards. Now, counteracting lift is weight, the force of gravity pulling the plane back down towards the earth. To stay aloft, an airplane must generate lift that's equal to or greater than its weight. That's why planes shed weight by burning fuel during their flight. Thrust comes next, the forward force that propels the airplane through the air. It's typically generated by jet engines or propellers. These engines suck in air, compress it, mix it with fuel, and then ignite it. The resulting explosion pushes the plane forward. But just as weight counters lift, there's also a force that opposes thrust: drag. Drag is the air resistance that a plane encounters as it moves through the atmosphere. There are two types of drag: parasitic, which includes all the forces that work against the forward motion like turbulence and friction, and induced, which is related to the generation of lift and increases as the plane slows down. All these four forces are in a constant dance with each other. For a plane to take off, the thrust has to be greater than the drag, and the lift has to overcome the weight. While in flight, these forces need to be in equilibrium for the plane to cruise at a steady altitude. And when it's time to descend, the weight and drag must exceed the lift and thrust. So the next time you look up at a plane in the sky, remember the four forces of flight at work. So what powers these massive beasts into the air? Well, it all comes down to the engines. The engines of an airplane are the heart of its operation, providing the necessary thrust for flight. Without them, an airplane would be as grounded as a car without wheels. Think of the engines as the equivalent of the muscles in your body. When you want to move, your brain sends a signal to your muscles, telling them to contract and generate force. Similarly, the engines generate the force, or thrust, that propels the airplane forward. As the plane moves forward, the wings interact with the air to create lift, which is the force that counters gravity and allows the plane to rise into the sky. But just as your muscles need fuel to work, so do the engines. Airplane engines burn fuel to create high-pressure, high-temperature gases. These gases are expelled out the back of the engine, creating a force in the opposite direction. It's Newton's third law in action, folks. For every action, there's an equal and opposite reaction. The expulsion of the gases backward pushes the airplane forward. Now, you might be wondering, how do these engines work in tandem with the wings to create lift? Well, as the airplane moves forward, air flows over and under the wings. The wings are designed so that the air moves faster over the top than beneath, causing a pressure difference. This pressure difference creates an upward force, or lift. And voila, the plane takes to the skies. Keep in mind that the engines also provide power for other essential systems on the plane. They keep the electrical systems running, power the hydraulic systems that control the plane's movements, and even provide the air conditioning to keep passengers comfortable. So, the next time you're soaring through the sky, think about the engines. They're not just large, noisy cylinders under the wings. They're the workhorses that make flight possible, tirelessly pushing against the forces of gravity and drag. Remember, without the engines, the plane would be nothing more than a giant paperweight. But what about the wings? What role do they play? This question leads us to the heart and soul of aviation, the magic of the wings. The wings of an aircraft are not just appendages for balance or aesthetics. No, they serve a far more significant role. The wings are the heroes of our story, producing the phenomenon we call lift. Let's delve a bit deeper into this. Have you ever wondered why wings are shaped the way they are? That unique curved design isn't just for show. It's called an airfoil, and it plays a pivotal role in making flight possible. Imagine the wing as a cross-section. The top is curved while the bottom is flat. This design is strategic. When air hits the front of the wing, it splits. Some air goes over the top and some goes underneath. Due to the curved shape of the top of the wing, the air traveling over it has to move faster than the air beneath it. Here's where things get interesting. According to a principle known as Bernoulli's principle, faster-moving air creates less pressure, so there's less air pressure on top of the wing and more underneath it. This difference in pressure creates a force that lifts the plane upwards. This, my friends, is the magic of lift. But that's not all. The wings also house the ailerons, small hinged sections on the outboard portion of each wing that allow the aircraft to roll and bank into turns. So the next time you look out of an airplane window, take a moment to appreciate those magnificent wings. They're not just there to give you a view or a place to hang the engines. They're hard at work, using the principles of physics to lift tons of metal, fuel, cargo, and passengers into the sky, defying gravity with every flight. The wings are a crucial component in the flight, creating the lift that defies gravity. How does a pilot steer this enormous machine in the sky? That's a question that has left many of us scratching our heads. So let's delve into the fascinating science of steering an airplane, a task that is far more complex than just turning a wheel. To understand this, we first need to familiarize ourselves with three key components: the ailerons, the rudder, and the elevators. These are the primary control surfaces of an airplane, and they work together to help the plane turn, climb, and descend. Let's start with the ailerons. These are small hinged sections on the outboard portion of each wing. They work in pairs, meaning when one goes up, the other goes down. This causes the airplane to roll, which in turn allows it to change direction. Think of it like tilting your head to the side, but on a much grander scale. Next up, we have the rudder. Located on the vertical stabilizer at the tail of the plane, the rudder swings left or right, pushing the tail in the opposite direction. This yawing motion helps the plane turn, much like how a boat's rudder helps it change course. Finally, there's the elevators. These are hinged sections on the horizontal stabilizer, also at the tail of the plane. By moving up or down, they change the pitch of the airplane, allowing it to climb or descend. Imagine raising or lowering your chin. That's essentially what the elevators are doing for the plane. So, how does the pilot control all of these? Well, by using the control yoke or stick and the rudder pedals. The yoke or stick is turned left or right to control the ailerons and rolled forward or backward to control the elevators. The rudder pedals, on the other hand, are used to steer the rudder. Steering a plane involves a delicate dance of ailerons, rudders, and elevators. It's a complex process, but with the right knowledge and skills, pilots are able to guide these enormous machines gracefully through the sky. And finally, how does a plane land safely? Imagine a bird swooping down to perch on a branch. It doesn't abruptly plummet from the sky, but rather, it gracefully descends, adjusting its wings and tail feathers to control its speed and direction. In a similar fashion, landing a plane is a delicate dance between gravity, speed, and precision. The process begins with the initial descent. The pilot, guided by air traffic control, starts to reduce the altitude of the plane, gradually bringing it closer to the ground. This is a carefully orchestrated process, with the pilot adjusting the plane's speed and direction in response to changing weather conditions and instructions from the control tower. As the plane continues to descend, the pilot begins to prepare for the final approach. This is where the flaps and slats come into play. These are movable surfaces on the wings that can be extended to increase the lift of the plane and slow it down. Think of them as the plane's brakes. As the plane gets closer to the runway, the pilot extends the flaps and slats further. This changes the shape of the wing, increasing its surface area and creating more lift. This in turn allows the plane to fly at a slower speed without stalling, making for a smoother and safer landing. The final touchdown requires the utmost precision. The pilot must align the plane with the runway, adjust the descent rate and speed, and carefully manage the plane's attitude. That is, its orientation in relation to the horizon. It's a delicate balancing act where the pilot must maintain just the right speed and angle of descent to ensure a smooth landing. Too fast and the plane could overshoot the runway. Too slow and it could stall. And then, with a gentle thump and the screech of tires, the plane touches down. The engines are reversed, the brakes are applied, and the plane slows to a stop. Landing a plane is a delicate art, requiring precision and skill to ensure everyone's safety. It's a complex process, but with the right knowledge and experience, it can be as graceful as a bird landing on a branch.